As x goes to negative infinity, y goes to 0. As x goes towards 0, y goes towards negative infinity. Look here. Left-hand side, does it ever go to the left of 0?
No.
So x is approaching 0. And as we go to that 0, what's y going towards? Negative infinity. This is why if you look at your graphic organizer from analyzing polynomial functions, I told a lot of you to be careful that left-hand and right-hand in behavior does not always go towards the infinities. Right? Sometimes it starts going towards those zeros. So then what would the right-hand in behavior be? As x goes towards positive infinity, y also goes towards positive infinity. Notice the x and y would still switch, they're just both infinities. Any questions before we move forward? Okay, these are a lot of the conceptual things. You need to know what these different terms mean and how to get these ideas. You do not have to just know the in behavior. A lot of times I'll let you graph it to be able to try to look at it and figure out what it is, but you have to know how to analyze each of these features leading up to our unit test or our exam next week, which we will have a test also probably early next week. Okay? Yes, sir.
Totally unrelated, but I heard we only have 1 week for Christmas break.
No, we got 2. We don't. Y'all don't come back till January 5th. I don't come back till January 3rd. I promise you, I would rage if I only had a week of Christmas break. I got too much stuff to do. All right. No one had any questions, so I'm moving to 3.1. Is that fair? All right. So, it's necessary to define a new function in order to write the equation for the inverse of an exponential function. The logarithm of a number is the exponent to which the given base must be raised to produce the number. Again, you have a graphic organizer, you need to use it. If you just put this definition, are you going to score well on that graphic organizer? You might get a 3, but take it a little bit of extra time to explain what this means and or give examples. Remember, this must be your study guide. I'm not giving you a study guide, you got your graphic organizers. That's the point of this, is that a summary that you can study for tests from, and also that you can take with you after this class in case these terms come up later. Yes, ma'am?
We're not getting a study guide in here?
That's what the Big Ideas graphic organizers were about, is to help you build a study guide of what to study. I might develop something else. Like, what are you looking for in a study guide?
Everything.
I don't understand what you mean by everything. Use your language.
Everything we've been over. Like, we did a lot of stuff and a lot of formulas. Like, that's a lot to keep up with.
But that's what the graphic organizer is for. That graphic organizer should have the different formulas. It has all the formulas. It has all the big ideas, big key terms. And that's why we're supposed to build like which lessons it went with, stuff like that. Okay? Now, if you want to sit down and talk through any of those graphic organizers, then I can. I have also started building a list of which lessons to look at, so I could possibly send that out in an email or something. Would that help you? Okay, so I'll send that out as well. I'll make sure I fill it out for all the stuff that'll be on the test. Okay. But yeah, the Big Ideas graphic organizers. That's why I did that, so that you had the study guide already. Okay. Okay, so if y is equal to b raised to the x, then x is the logarithm and can be written as log base b of y equals x. Literally, I want you to notice that detail. Y equals b to the x versus log base b of y equals x. So when I take a logarithm, what am I getting? X, but what is x?
It's the
Inverse.
exponent.
It's the what?
Exponent.
It's the exponent. Like, and that's what people make logarithms super complicated, but all that the logarithm is the exponent. And that's what this definition is saying. A logarithm is the exponent that goes on the base.
You got logarithm in there twice.
Huh?
You got
Logarithm,
on there twice.
is it one logarithmic expression, one logarithmic function?
No, they both just say logarithm in motion.
Well, then I made a mistake. Oh, it kind of comes back up in a slightly different way there, but I did make a mistake.
Okay.
That goes on the base to get the argument. There are some key words here that you need to make sure you accurately define: the base and the argument. Notice how they give the definition right here. The base of the logarithm, notice that'd be the same as the base of the exponent. So if I were to rewrite this log base 2 of 8 equals 3, what would be the base of my exponent? Or the base of my power, I should say. 2. What would be the exponent of that power? 3. And what does that equal? 8. That is all that we're saying, right? When you see log base 2 of 8 equals 3, what you need to ask yourself is, what exponent goes on 2 to give me 8? Well, the exponent is 3. That's all a logarithm is. What exponent goes on 2 to give me 8? The exponent is 3. 2 to the third, remember, is 2 times 2 times 2, which is 8. And they give us quite a few examples here. Right? So examples, very generic. Here's an exponential form though. 16 is equal to 4 squared. So what is the base of my logarithm?
2.
4.
It'd be base 4, right? Isn't the base of the logarithm the same as the base of the exponent? So that would be log base 4. Right? Of 16 is equal to, because remember it needs to equal the exponent. What exponent goes on 4 to give me 16? That's all a logarithm is.
So you need to find the exponent for that
The exponent that goes on the base
to get you that number.
to get me that number. It is called the argument.
Okay.
That's all it is.
So,
So what, Gracie?
I know that 2 to the third would equal 8, but, oh, you took it out of the form. Okay, never mind. It makes sense now.
Okay. You good, CD? Good? Anybody got questions? Need to get some practice with it? A little bit? Yeah. And so, I will say this. This is something that's in the book called the triangle of power. I've never seen it before. The book likes it. So if you like it, go for it. The way that the triangle of power works is this. You have your base, you have your argument, and you have your exponent. It helps you write both an exponential expression and a logarithmic expression.
Oh,
If you don't like it, don't do it. Huh? The argument. Yeah, the argument is what you're taking the logarithm of. And I will say this. Notice how they say log base A of B equals C? That's not how I write it. I write it this way. And I think it makes a lot more sense. Any guesses why I use B here? Base. Any guesses why I use A here? Argument. And then N is traditional for an exponent.
so argument is what you're trying to get?
You trying to get the exponent equal to argument.
You're trying to get it so that your base here raised to that exponent is equal to the argument. So like if I were to give you log base 3 of 81, the answer is a what? Just in general, what is the answer to a logarithm? It's an exponent, right? So what I'm asking is, what exponent needs to go on 3 to get me to 81? Any guesses? You can also use a calculator to help you play around with it. Huh? So 3 to the 9th is equal to 81? I don't think so. Yeah. Maybe something a little bit smaller? That got real loud real quick. I will say this, some of us are making it a little bit,
No,
a little too difficult. Hey, what's 3 times 3?
No, it's not that either.
No.
It's 4. Oh.
It's 4?
Yeah, that's 4.
Okay? Because remember, what is 3 times 3? 9. 9 times 3? 27. 27 times 3? 81. 3 to the 4th. right? Literally, what's the exponent? What would I need to repeatedly, how many times do I need to repeatedly multiply by that base to get that number? Okay, maybe 4. Okay. Really quickly, I will point this out. Restrictions on x, right? Or in our case, n. So if you want to, you can leave these variables like this. That's fine, I guess. Anyways, looking here, is there any number that x cannot be? Can you do b raised to the 0?
I mean, you can.
You
but
can.
it'd be like 1.
It would be 1. So can you have an x value of 0?
Yeah.
Yes.
You could, yeah, you gotta get to 1.
And also remember, in general, okay, so what would y equals b to the x look like?
Wow. Oh, you're gonna be a line.
It's gonna be a line like this?
No, well, it depends, if it's raised to the 4th, it would be like that, if it's raised to the 3rd.
But remember, x is a variable. And you're thinking of polynomials. You're thinking of x raised to the 3rd. Remember, we're looking at an exponential expression where the variable is in the exponent.
Well, you wouldn't know because the x is the variable, so
Yes, you do.
it's a line for it. Like
Why don't you look at the previous page?
It's like a, yeah.
Oh, you mean it's an exponential function?
Sure.
It's got an exponential curve to it, right? Tell me,
Why?
what is the domain of that function?
Infinity.
I don't know.
What's the domain of that? We just did it on the previous page.
Infinity.
Negative infinity to infinity, right?
Yeah.
So is there anything I cannot plug in for x?
No.
None. Explanation, right? Domain is negative infinity to infinity. Remember, what we're saying is we can plug anything in for x. Same thing is going to be true for the x in the logarithm. There are no restrictions on it. Okay? Now, what about the base? Were there any restrictions on the base for exponential growths and decays? Were there any kind of numbers we could not have?
I think it was a number less than 1, and no number that was greater
Oh,
than
it had to be
1.
So remember, between 0 and 1 was an exponential decay.
So it couldn't be a
Yeah,
negative.
It couldn't be a what?
A negative.
A negative or
Zero.
0. Right, so the base has to be greater than what?
1.
It has to be greater than 0.
What did we just say? If it's between 0 and 1, it's an exponential what? Decay. So can it be between 0 and 1?
No. Yes.
Can it be between 0 and 1?
Yes.
Yes. It would just be a decay instead of a growth.
Yes. It just can't be
Okay.
negative.
It just can't be negative or,
A 0.
so it has to be greater than 0.
Okay.
Right?
0 would be negative.
And reasoning 0 to the x is 0, and a negative b to the x. Remember we talked about it before, that would switch between being positive and negative. Right? And so that's why it's not an exponential growth or decay. And also you start getting into imaginary numbers and stuff like that.
Can it be an imaginary number?
Huh?
Can it be like a positive imaginary?
No, because at least on these functions it wouldn't work. Technically, you can work in the complex coordinate system, but no.
What about a number that just continues forever?
Irrational?
Can it be?
Yeah. Okay, what about y?
Why? Why? I think y gonna be the same thing as x.
You think so? Look at the graph again. 0.
Which one is y again? Like, what letter did we use?
In a logarithm,
You did not just underline the y and tell me that. I know that that's y.
so this argument is what they're using as y. But remember, this y here and this y here are the same thing. They're just inverses, right? So what are the restrictions on y in the exponential function? Greater than 0. So it has to be from 0 to infinity.
It can't be a negative.
Well, I mean, look at it.
It's not negative. But it can be a negative. It goes to negative infinity, what you said.
But, LaShannon, which variable are we looking at?
We're looking at y.
which is my range, not my domain, I'm looking in this direction. Can it go below 0? No. So remember, what a logarithm is saying is, what is the exponent to get this argument? Tell me this. Is there anything I could put 4 to any power, will it ever equal negative 16? No.
Oh, because you can't do a negative exponent.
Well, even a negative exponent, what does a negative exponent tell me to do? To divide. So would I ever get a negative? No. So can that argument ever be negative? No. Notice, the argument of the logarithm is the same as the output for the exponential. Neither of those can be negative. Okay? Don't know why I have this in here twice. Doesn't say anything. So draw triangles of power to illustrate each equation, then rewrite in exponential form.
You just rewrite it in exponential.
I would go with that personally.
I
Okay?
just like the triangle of power.
So you can do the triangle if you want to. Notice it's base. I think they have argument and then exponent. So then the base is 10. The argument is 1,000, but, and see, this is why I don't like it. What's the exponent on the 10? X equals the argument of 1,000.
Oh, so it's always gonna be, like that, it's not gonna change when you try to find the.
Remember, base, the base of the exponential expression, the base of the logarithm are the same.
Yeah, but I'm
This is my exponent.
I'm assuming they change the numbers and variables, that's what I was asking.
Yeah, like the triangle power, they put the,
X at the top instead of.
Well, but look again at what they had. It was log base 2 of x equals 3. So the base is 2, the argument is x, and the exponent is 3. Here they have log base 2 of 8 equals x. So the base is 2, the argument is 8, the exponent is x. So they have a different logarithmic expression for each of those. That's why it's that way. Yes, sir? Huh? Be quick. Just a couple minutes left. So with b, what would be the exponential expression? So base raised to the exponent is equal to x. Notice sometimes it's going to be easier to think about it as an exponential expression. You have to make a decision about when it's easier to think about it as an exponential expression. It's on the same page, isn't it? Or on the one to the right? It's literally one page to the right.
I was doing these right here.
So the base is the log.
So can we leave it like that? I
Well, it's the logarithm of the base.
Yeah, that's what I'm saying, so that's the base.
That's the base.
And then the exponent is the 5 right there at the end.
So remember, what a logarithm is an exponent. So the logarithm equals the exponent, and then it's of this argument. And the argument is the output for the exponential. Now, don't leave it like this, CD, because put that in a calculator, you get 5 to the 5th. Okay? Right, I have no idea. I know 5 to the 4th is 625, so maybe 3125?
Yep.
Holy cow, that's some rain. Yeah, see ya. Bye, y'all.
You know, there's a chance.
Oh my
I did hear that. Oh my gosh. I'm pretty sure someone would die in that rain. Okay. Sorry, that was a little messy. Alright, looking at this, any guesses what the exponent would be? What x is equal to?
10.
Sorry.
Put 10 to the 4th then into the calculator. Is this cracked? You've got to be kidding me. I'm gone one, not him, but like, I'm gone one day and they crack a screen. Just like kids stealing a calculator.
Hey, I'm confused.
And 10 to the
So
it's 10 to the 3rd because it has 3 zeros.
What?
I can't explain why 10 to the 3rd and then.
Put it in the calculator. What's 10 to the 3rd?
10 to the 4th.
Yeah, what I'm saying though, like, how you want to explain it? Like,
Well,
10 raised to the x
10
equals
raised to the
1,000.
x is 1,000.
1 times 10 times 10 times 10.
Okay, that's.
Right?
What did it equal?
So then C,
And it has 3 zeros.
x
1.
I mean, one.
raised to the first is equal to,
9.
so what does x equal?
100.
Oh, you equal to 1?
No, Nine.
1 to the first is equal to 9? Remember, 9 to the first is equal to 9.
I'm sorry. So it was x raised to the first equals 9. Okay. For the first one, did y'all, for x, did y'all get 100?
It's 10 to the third.
But then why, if you divide it, it down.
So this is the last detail we'll cover. Notice how they have, oh, and then b also can equal 1. So a logarithmic function is a function that involving a logarithm, right? What do the graphs of logarithmic functions look like? So notice how we have b raised to the x. What kind of function is that? So exponential, right? So sketch the graph of the inverse of h of x on the same coordinate plane. How in the world would I be able to get my logarithm from this exponential? Okay, mirror it, switch our x and y, but notice we don't have actual coordinates or the grid system. You could approximate, but remember, what do we know about an inverse function? It is starts with an R. It's a reflection across y equals x. So I would sketch in y equals x, and I would approximate the reflection across that. Remember, we know some key features. There's an asymptote right here. What is your logarithmic function approaching? 0, or specifically x equals 0, right? That y-axis.
Teachers and students, please pardon this interruption. Just a quick announcement for juniors. For those of you who missed the ACT test last Wednesday, the makeup is scheduled in the library tomorrow at 3:30 until we complete. That is Tuesday, December 7th, 3:30 in the library with me, and we will get that test.
Please make sure you get those points labeled on the graph. That's what
Also,
we'll
as
pick
a
up
reminder,
tomorrow.
check your yellow manila folder for the date that your test correction is or is completed. Y'all have a great day. Bye.
So, notice here is the homework for this week. Look, we already have graphic organizer through asymptote, or we should have it done. Notice we have a new asymptote to add to it, right? The asymptote for the logarithm. So we have inverse function to define, logarithmic function. We did not get to common and natural. We'll get to that tomorrow. Here is some homework that I had already told y'all about. It is 3 problems that is due tomorrow, and then the graphic organizer, LaShannon, is due on Thursday. We'll get through most of these terms tomorrow / early Wednesday. Yep. Okay. That should say Tuesday we're going to work with logarithmic functions and operations. Yes, ma'am. Not a good time?
No.
Sorry.
All I see just was cosine and t something, I don't know.
Tangent.
Tangent.
Yep. Trig ratios. Again, y'all, if you could, please help me find my calculator, bring it home. ZD, where'd you put that calculator that's correct? Huh?
Mr. Dina.
She said we're gonna start
Okay,
going back
yeah.
soon, but
If
I
not,
don't know when soon.
Yeah.
this is until 4, right?
Turn in. Yes. And if you're close to finishing something, I can say a little bit later.